Fall is almost here, but we're still having some really hot temperatures. We often rely on evening and night temperatures during the summer heat for temporary relief. On this episode of Weather Eyes, our meteorologist Dylan Hutler is helping us understand radiative cooling process.
Welcome back to Weatherwise. I'm your host, meteorologist Dylan Hudler. Today we're going to get technical. We're going to be fancy and talk about this meteorological phenomenon called radiative cooling. Ooh, radiative cooling, right? No, I'm just kidding. It sounds really fancy, but it's very simple. Radiative cooling is basically just the process of why temperatures are cooler at night than they are during the day, why it's warmer during the daytime and temperatures drop at nighttime. It's a fairly simple process to explain. We start off in the morning with those cooler temperatures. You know that during the day, the sun radiates energy down into our surface like these yellow arrows are representing. So we go from the morning time and then to the afternoon time when that heating is at its peak. For example, we reach a high near 71 degrees, the air temperature at the surface. That's what we're feeling outside. And during the daytime, it's all because the sun's radiation, like I mentioned, heats the earth during the day. Now at nighttime, when the sun goes away, that warm air and radiation is able to lift back up and rise and return into the atmosphere. So temperatures get cooler down here at the surface. We went from, say 70 degrees down to 43 degrees, feeling cooler at night. So that heat rises, and in turn, cooler air has to rush to fill that void in at the surface. It's faster if there's clear skies above it, and it allows that cooler air to rise more freely. There's a couple different scenarios we talk about when forecasting overnight low temperatures. The first being if there's cloud cover. We'll look out for cloud cover because that radiation that's trying to rise from the surface at night and cool things down is kind of trapped by those clouds. It's like a blanket overhead, so the clouds trap the heat, and some of that heat returns to the surface. It's held really low, and so we're not able to cool off as much. And then on the other hand, over here, there may be a layer of increased wind flow present in the atmosphere, like this arrow represents. So that radiation rises up a little bit but interacts with that wind flow and is forced back down at the surface. So we may be a little bit warmer in a scenario like this. The ideal scenario to have a cool, crisp night, waking up maybe feeling like fall, is with clear skies and light winds. That allows the radiation to rise freely. We're able to cool off to the maximum potential. Temperatures are able to get lower when there's clear skies, light winds, and dry air. Sometimes when it's really humid at night, that moisture sucks up some of that energy and holds it here closer to the surface, so we're not able to cool down as much. But with that dry air, really a big difference, making it feel less humid outside and also allowing temperatures to get cooler. That's basically radiative cooling explained. So now you know why it's warmer during the day and we get cooler at night. Just a nice little interesting tidbit to share with you guys this week. As always, if you have any questions, comments, or maybe want to suggest a future Weatherwise topic, you can send us an email at weather@wcbi.com, or feel free to send us a message, leave a comment on Facebook, Twitter, or our Instagram page. That's all I have for you today. Go out and tell your friends. Now you know what radiative cooling is. Gosh, you'll blow their mind. Have a good one, y'all.
Weatherwise is brought to you by Fort County Electric Power Association.